This is the third video of chapter 3. We are at section 4, matter cycle. This video is packed with information, so pay attention. When we look at a carbon cycle, so we would focus on carbon dioxide. So when we look at carbon dioxide, we would remember producers remove carbon dioxide from the atmosphere, and consumers produce carbon dioxide. Also remember, for carbon, some of the processes takes a short time to cycle. Some of them would take a long time to cycle, such as if you have a plant in front of you, and then the plant produces carbon dioxide, you breathe in and you breathe out, and then very quick. But some of the carbon, if they are buried underground, would go through the millions of years into the fossil fuel, right? So the important thing you needed to know how humans alter carbon cycle and what are the consequences. So humans alter carbon cycle by burning fossil fuels and deforestation, two things. So as a result, overloading the atmosphere with carbon dioxide. And then what is the effect about so much carbon dioxide in the air? This one causes global warming. Another thing about carbon cycle you needed to know is the largest reservoir, the area store most of the carbon, is the ocean floor. So the marine sediment hold most of the carbon. So the next diagram just to show you the steps of a carbon cycle, and then the red one shows how human alter the cycle. So you can see it's from burning fossil fuels, and then forest fires caused by climate change, and then other cutting down of the trees, and then transportation is another way to use fossil fuels. Okay, and then we are looking at nitrogen cycle. For nitrogen cycle, one important thing you need to know is the heroes of nitrogen cycle are bacteria. So the largest reservoir, the storage room for nitrogen, is atmosphere. So the air around you, 78% is nitrogen. However, this huge amount of nitrogen, you and I and other plants, other animals are not able to use. So what is nitrogen fixation and why it is important? So nitrogen fixation, this definition you need to know, okay? Nitrogen fixation is a process in which nitrogen gas in the air is converted into compounds that plants and animals can use as nutrients. Without it, why will I say it is important? Without it, plants and animals cannot survive, since they cannot use the nitrogen in the atmosphere. So if nitrogen fixation is so important, how does it happen naturally? So two ways. One is lightning. So with a strong energy, they can convert the nitrogen gas into a compound. But mostly it's by bacteria, and especially cyanobacteria. So those bacteria, they combine gaseous nitrogen, N2, with hydrogen to form ammonia, NH3, and ammonium ions, NH4, with a positive charge. And then some other bacteria can do further job. It's called nitrification. So those are the bacteria in soil. So they change ammonia and ammonium ions to nitrate ions, NO3 with a -1 charge. So these form, nitrate ions, are very easily taken by the roots of plants. If the plants get nitrogen, and then all the other consumers, when you consume plants, you get nitrogen you need. So this is important. Also, we have some other bacteria. They do the job called denitrification. So this one, those bacteria, they turn nitrate ions back to nitrogen gas. So they finish the whole nitrogen cycle. So humans alter this cycle by 4 ways. So you need to know this one. So number 1, so we add large amounts of nitrogen oxide to the atmosphere. And when we burn fossil fuels, since nitrogen just in the air, when you burn, so nitrogen participate, they produce nitric oxide. And then later on, this one is converted to nitrogen dioxide and then to nitric acid, which contributed to acid rain. The second way, we also add nitrous oxide, N2O, to the atmosphere. This one is a greenhouse gas. So how do we do that? So when we use nitrate fertilizers. So what are fertilizers? Those are nitrogen fixation by human method. We are able to produce fertilizers. Okay. So this is because the action of anaerobic bacteria on commercial nitrogen-containing fertilizers or organic animal manure. So the bacteria work on those fertilizer, and then they produce nitrous oxide, which is a tremendous greenhouse gas. The step 3, we also remove large amount of nitrogen gas from the atmosphere faster than the cycle can replace it when we make fertilizers. With the modern technology, we can do nitrogen fixation, but meanwhile, we cause problems. So number 4, so we upset nitrogen cycle by adding excess nitrate into aquatic ecosystems through agriculture runoff of fertilizers and animal manure, and through discharges of municipal sewage treatment systems, which cause eutrophication. You needed to know eutrophication. So eutrophication is too much nutrient in water system, cause extra growth of algae, and then later cause more trouble down the road. So this is the model of a nitrogen cycle, and then the red part again are the steps where human impact the cycle, the 4 steps we mentioned previously. And the next one, we're looking at phosphorus cycle. So for phosphorus cycle, the largest reservoir is the earth, the rock and the sediment. And then the phosphorus cycles through water, through Earth's crust, and through living organisms. But phosphorus cycle does not go through the atmosphere. So if you are asked, what is the difference between phosphorus cycle then nitrogen carbon, you would say phosphorus cycle does not go through the atmosphere. Okay, so impact of human activity. So when we cut down forest and then we make the phosphorus cycling not balanced, we remove a large amount of phosphate from the earth to make fertilizers. So take them out from the land, apply to the living thing. However, when erosion happens, when runoff happens, all the phosphorus you applied as a fertilizer will get into the aquatic ecosystem. Also, the insufficiently treated sewage also make the excess phosphate into the water, also cause eutrophication, which is excess growth of algae, and then cause more problems. And then this is also the models, and then the red arrows are the human impact we mentioned in the previous slide. When we look at sulfur cycle, so most sulfur found in rocks and deep under ocean sediment. We do have sulfur dioxide in the atmosphere. Naturally, they are released by volcanoes. we're not able to do much with volcanoes. However, human activity also add more sulfur dioxide into the air. And then as a result, this one is the main ingredient of acid rain. So how do we cause that? So one, by burning coal and oil, but mainly it's coal. And then also during the refining process of petroleum, we release this one. And then when we purify the metals from mineral ore, the process produces sulfur into the air. This is the model of sulfur in nature, and then the red steps are all human negative impact. Smelting, burning coal, and then refining fossil fuels. Add too much sulfur dioxide in the air and then causing acid rain. Okay, we are at the last section, mainly talking about how scientists study ecosystems. I will quickly summarize. The study ecosystems has two ways. One is you do research in the lab, and the other one you just do observation measurement in nature. So your nature observation is a part of the natural observation. And then for natural observation, now we have a new technology like remote sensors, and then GIS, and then digital satellite. So a lot of new technology can do what we were not able to do earlier. So in the lab, you just use a simplified system, and then to make models like a computer model, mathematical model. But one thing you got to know is both of the field research and the lab research, you need a baseline. So many of the universities still doing those baseline, because baseline is important. Without a baseline, we don't know how much we have degraded the ecosystem. Okay. And then this slide, you have two terms to learn. We needed to know the era change. So we divide the time into two. One is before the Industrial Revolution. So from the last glacial period to human industrial revolution. This part is relatively the environmental stable. We call them a Holocene era. However, after the Industrial Revolution, human became the main character, changed the environment. So we call this time Anthropocene era. Okay, so these two terms, if you see in multiple choice question, you should know what that meant. And then lastly, so scientists have made 10 planetary boundaries to say humans should not cross, because that would be dangerous. However, among these 10, nitrogen cycle, carbon cycle, and climate change and biodiversity loss, we have crossed the boundary. That means we have made tremendous damage to the environment. So that's why you are in this class. We got to rise up together to change the situation, to make the earth a better one. Okay. So lastly, remind you, life is sustained by three things: the flow of energy from the sun through the biosphere, the cycling of nutrients within the biosphere, and then finally gravity holds on everything towards the earth, especially the atmosphere, for us to breathe in. Okay, this is the end of chapter 3. Thank you for watching. Hope you do well on the quiz and test, eventually on the AP exam. Okay, bye for now.